All right, let's do a little geometric proof. Given that segment AB is congruent to segment AC, we're going to try to prove that angle B is congruent to angle C. So I have this drawing, this triangle ABC. I'm going to end up drawing this little bisector here. I drew it dotted right now, so pretend like that's not there right now. Pretend like I just have this triangle ABC. Pretend like you don't see this right now. So I'm given this and I want to prove this. So when you're trying to do a two-column proof with statements and reasons, the very first statement you want to make is your given statement. So I'm going to write this down and say that it's given. It was given to me before the problem started. So what I know is that this segment right here, AB, is congruent to that segment. In fact, I could go ahead and mark that. Give me just a second here. Let me grab my pen. So I'm going to mark that. I'm going to say this is the same as that. So those two are the same by this given statement. And then what we're going to do is we're going to construct a bisector of angle A. So I'm drawing this segment here, and I'm saying that it bisects it. In other words, this is going to be congruent to that. And the reason is every angle has one bisector. So I did that. And from that, it follows that this angle BAD, is congruent to angle CAD. And that is by definition of angle bisector. So the fact that I bisected this, that these two angles are the same, comes by definition of what an angle bisector is. An angle bisector is a segment that cuts an angle into two equal parts. This angle is equal to that angle. So angle BAD, that angle, is congruent to angle CAD, that angle. So that's my third step here. And of course, AD, this segment, is congruent to itself. So this segment is in that triangle, but this segment is also in this triangle. And so AD is congruent to itself because of the reflexive property. Now, if you don't know the reflexive, symmetric, and transitive properties, then you need to memorize those. Go back and really learn those. Put them on 3x5 index card and memorize those. So something is congruent to itself is called the reflexive property. So at this point, I've cut this into two triangles and I have a side angle side congruency. So I'm going to say that triangle ABD, in other words, this triangle, is congruent to triangle ACD, this triangle ACD, this triangle here. But those two triangles are congruent because of the side angle side postulate. So there are a bunch of postulates that prove that triangles are congruent. And one way to do that is if you have a side, an angle and a side that are congruent in two different triangles. If you have just two congruent sides, so this side is congruent to that side, and this side is congruent to itself, and an angle in between them. That's called side angle side postulate. So I'm proving that this triangle is congruent to that triangle, which means all the angles are the same, all the sides are the same, based on just three pieces of information: that they have a side congruent, another side congruent, and an angle in between them. So I'm saying those two triangles are congruent by that side angle side postulate. Now there's an angle postulate. There's an angle side angle. There's a bunch of different postulates, but one of the most famous is side angle side. That's what this stands for, side angle side postulate. And so I'm saying that the two triangles are congruent by that postulate, and that means that all of the sides and all of the angles are congruent. In other words, I could go ahead and say this is congruent to that, and I could even say that this angle right here, of course, I'm going to put one mark there to say that those two angles are congruent. But by that, I could also say those are congruent. And then last but not least, the very thing I am trying to prove, this, that these are congruent. So angle B and angle C are congruent. And that is my last statement, which is the thing that I'm trying to prove. And I'm going to say that's that they're congruent by CPCTC. Corresponding parts of congruent triangles are congruent. So this is a proof. So a proof is a systematic way of showing that something is true, given some statements, given some reasons, using postulates and properties and theorems and things like that to logically show that something is true. So you're taking some given information, you're adding some postulates and theorems and definitions and things like that to it to prove beyond a shadow of a doubt that something is true. And in this case, we were proving that angle B, this angle, was congruent to that angle. Now, from this, we know that angles that are opposite congruent sides are in fact congruent. So this side is congruent to that side, so the angles opposite those have to be congruent also. And what we've done is we've proven that. So this is the Isosceles triangle theorem. So I'm showing that angles opposite congruent sides are congruent, and I did that by showing that the two triangles were congruent, and so their corresponding parts are congruent as well. Anyway, so I would play this video over and over, search this out. I would, if you're struggling with geometric proofs, then go to YouTube, and instead of watching some stupid TikTok video, search some examples of geometric proofs that are worked out and explained, and go over and over and over them, and even try some on your own from scratch, and then play a video back and see if you can get better at these proofs. They're not easy. It's not simple. It's going to take some effort to really get better at geometric proofs. It's not something that's for the weak at heart. It's not something for those who are simple-minded. It really will stretch you. When I was a high school student, I really struggled with this. It's gotten easier as I've gotten older. It's gotten easier as I've done a ton of examples, but man, I remember this being super difficult when I was in high school the first time I encountered this. So it really does take a lot of practice. Thankfully, I had a teacher that would let me come in after school and before school and ask questions, and he explained things over and over and over, and he was very patient with me. And I don't know if I ever got good at it while I was in high school. I wouldn't say that, because I don't like to lie, but somehow or another I managed to pass with a somewhat decent grade, but it was because I just hounded him to death. I went in before school, I went in after school, and I asked questions, and he explained things over and over and over, and I managed to survive. As I've gotten older, they have gotten a lot easier. I see the connections now between starting with some information and then figuring out what information you need to add to that to show that something is true. I would liken it to really when you're trying to prove anything to anybody. So, you could make a statement that, that something is true, and then you would set about to give 3 or 4 reasons as to why it's true, and hopefully it would make logical sense to the other person. Another example would be when a lawyer in court is trying to prove that somebody is innocent or that they're guilty, and that lawyer is going to bring some facts to bear on the case and hopefully prove innocence or guilt that way. But they're giving statements, and they're giving reasons why those statements are true, and then hopefully the jurors can follow the logic and then agree that somebody is guilty or innocent. So it's kind of like that. But people argue all the time, and they give reasons. Like I could say, the Dallas Cowboys is the very best football team in the NFL. So you can make that statement, but the question is, can you prove it? And maybe you would bring some proof by statistics. You could bring their record in terms of wins and losses. You might even bring some stats related to running yards or passing yards or tackles, rushes to the quarterback. I mean, you could bring lots of different things to that picture to kind of prove that they are or aren't. By the way, the Cowboys are not, but if you were trying to prove that it was, you would bring some statistics to that. You might bring championship records and things like that. You might talk about their stadium, which I've been in that stadium. That is a great stadium. Maybe that would be a good given, is that their stadium is amazing. But the rest of it's going to be hard to sell for the Cowboys. But hopefully you get my drift, that you're bringing some reasons to bear on the thing that it is that you're trying to prove. So for geometry, if you don't know the properties and the postulates and the definitions and things like that that are going on in the chapter where you're doing proofs, if you don't know those things really well, you're not going to be able to use them. You're not going to bring them to the table when you need them. So the very first thing you need to do when you're trying to prove is you need to know the definitions, the postulates, the theorems, all those things. You need to know those very, very well. If you're not making use of 3x5 index cards and memorizing those and flashcarding yourself every day a couple times, you're just going to be mediocre at best when it comes to geometric proofs. You might as well just go ahead and settle that. You're not going to be great at it. You've really got to know the definitions well. Well, have a good one. This is a little geometric proof example. See ya.